The modern vehicle, equipped with a wide range of technical accomplishments, it offers its passengers comfort, safety, and driving pleasure. New systems consistently simplify driving and provide drivers with assistance in constantly increasing traffic. Naturally, this technology is the product of immense development efforts. Even after more than a century, the development of the automobile is not complete. To the contrary, today the vehicle requirements are higher than ever. Legislative requirements and the global competitive pressure in the industry are forcing manufacturers to launch new models faster and at lower prices, while simultaneously increasing the quality. On average, the development of a new model currently requires 5 years. 95% of the necessary road tests are performed by people. These tests can be divided into the following categories: endurance testing, rough road testing, driving dynamics, and driving maneuvers for assistance systems. Endurance tests in particular require test drivers to clock thousands of kilometers in only a short period of time. These tests are largely performed on public roads. This in turn creates additional traffic. The public reacts sensitively when these vehicles are involved in accidents. The rough road test is a perfect example of the stresses and demands placed on humans and materials. Tests for driver assistance systems demand a high degree of repeatability and precision. Complex traffic situations involving multiple vehicles are reproduced. Because of the required complexity, a large number of these tests have to be excluded from the evaluation. The physical limitations of both humans and testing carried out on public roads reduce the efficiency of the tests. Automated Testing Ground, or ATG for short, provides a complete solution. The services consist of the installation, the execution of the ongoing testing, along with the evaluation of the tests. The unique aspect of these road tests: the vehicles are unmanned. The test vehicle maneuvers without a human driver, on its own. In a collaborative project between Capgemini, Dornier Consulting and MB Tech, the individual companies have contributed their know-how in order to advance the development of a complete system for automated driving. The goal of the project is to provide industrial automated vehicle testing operations. A reliable driving robot forms the basis for autonomous driving. The model has long been in use on a daily basis on roller dynamometers. The flexible architecture allows every vehicle to be adapted individually. For example, the e-throttle can be controlled directly via the CAN bus, while the driver's seat remains empty. The IMU is another component. This is a gyro mount which works with differential GPS and thus guarantees exact positioning. The system is also capable of generating driving dynamics parameters for precise control and as a means of bridging short GPS service interruptions. An embedded controller is the central unit in the test vehicle. This controls and monitors the corresponding devices. This computer handles all of the communication between the vehicle and the control center. A variety of aerials are mounted on the roof for receiving GPS data and exchanging control and measurement data between the vehicle and the control center. All of the communication takes place via the new LTE cellular service. Thanks to its large bandwidth, the modern communication network enables the transfer of large quantities of data with low downtimes. As such, video streams and important vehicle parameters can be transferred simultaneously for live monitoring. Furthermore, the widespread coverage offered by LTE is a decisive factor for reliable communication with driving objects. The mobile control center is the heart of the system and handles the complete test coordination. The entire testing procedure is planned, controlled and evaluated centrally. Every vehicle movement is specified here. The constant comparison between the target and current positions guarantees precise and complex driving maneuvers, even in traffic with other vehicles. In addition to monitoring, the visualization of the test run also enables the simulation of complex traffic situations with virtual vehicles. As a central node, the control center guarantees a high degree of testing safety. None of the vehicles moves autonomously. Every movement is controlled by an administrator. There are multiple safety areas in order to safeguard the vehicle movements. These geofences are also controlled by the control center. The entire testing ground is divided into different zones. This enables a form of access control to be set up for every vehicle. Geofences secure the vehicle's immediate surroundings and define the route along with the boundaries of the entire testing area. In addition, every vehicle also possesses a robust laser scanner for monitoring the area ahead of the vehicle. In the event of danger, these safety systems prevent a collision and initiate evasive maneuvers up to and including emergency braking. The advantages of driverless testing open up an entirely new range of vehicle testing options. ATG reduces the scope of the classical ranges of road tests and simultaneously lays the foundation for the requirements of future vehicle testing. The concept enables many relevant test situations to be moved away from public roads and into a controlled testing environment. Utilizing this new technology increases the efficiency of the tests. At the same time, the test results can also be utilized as the basis for certifications. Complex traffic scenarios can also be reproduced in order to test alternative drive systems such as electric vehicles. The driving dynamics tests only stress the material itself, safeguarding human health. The potential cost reductions are immense. In addition to obvious benefits such as personnel costs, the reliable planning, the high reproducibility, precision, and diversity offered by automated testing also make an effective contribution to faster and better vehicle development. ATG can be added to every existing infrastructure, such as the customer's own internal testing grounds, for example. The services range from installing ATG equipment at the testing grounds to performing the tests to evaluating and managing the measurement data. This leaves vehicle manufacturers free to concentrate on their core competencies and profit from the complete support. This is what distinguishes ATG as a comprehensive service. Automated testing ground, the future of vehicle testing.